Good afternoon, everyone. This is Bharat from EDS Technologies. I take care of sales, uh, and I welcome all for this session on model-based definition 3D master. Uh, Thank you for taking out your time and joining for this session. So before going ahead with the presentation, I would like to give a brief introduction about EDS Technologies. I hope most of you know about EDS Technologies. Yeah, we are a 25-year company established in 1994, majorly focusing on PLM solution sales, implementation, and support. And we have been the sole partner for about 23 years during our 25 years of journey. And we are headquartered in Bangalore, presence across 11 locations across India. We are present across all major cities in India. We are the largest PLM and engineering solutions provider in India, serving about 1,500 customers, and we are also strategic alliance with many other world leader companies apart from the source systems. And we have very good manpower, employees who are dedicated to sales, support, marketing, and customer satisfaction audit teams, addressing PLM business and support requirements. We have a robust e-learning portal with focus on software and domain applications related to engineering, and we have all complete integration, system integration skills also. And from here, this is a brief about EDS technologies. Without wasting the time, we can go ahead into the session. And I have Mr. Kiran MS with me, who has been working with EDS since about 9 years, and who also comes with a strong domain background of automotive, NPD, and heavy equipment machinery industry. He's a senior solution consultant on Dassault System Solutions, responsible for understanding customer requirement and ensuring implementations in various industry domains such as automotive, aerospace, general engineering. And I would like to invite Kiran to take over and go ahead with the presentation. Over to you, Kiran.
Thank you very much, Bharat. Very good that we have an introduction with about our company. Okay. So just like quick, we start with today's planned on topic that's on model-based definition on 3D master, and we'll try to see what are the what are the importance that we get it from 3D master and as such. Okay. So first we'll understand the present, what are the scenarios and why it is prompting us to the 3D master. Why not 2D drawing? Or on the other way, we can say how this 3D master is dominating on 2D drawings and other things. So the one thing is when we say engineering, when we say design, any tangible product we talk about, it goes with dimensions. Without dimension in our shape or nothing, we cannot constrain. So when we say a dimension, we are basically giving a value for it, like whatever the product you may have it, whatever the product you have it in front of you right now, it has its own dimension. It is defined. When we say dimension, it is constrained by the geometry. When we say that, so we have its position, size, and detailed design and other thing, model shape and all those things. So when we say engineering dimension or a CAD dimension, or it is a design dimension or whatever it is, it's basically size and position we talk about. We know that what is the position, what could be from our reference, what is the position and all those stuff. And why this position and size and very much important when you go for manufacturing. And the manufacturing in the dimension will also prefer, or we always give some tolerance, acceptable tolerances, like you can say intentional tolerances. So if it goes beyond that or below that, it is rework or scrap or whatever it is. So the dimension gives the variety. It gives the variety of design product variants, or like we can say drive product capacity derived from business needs. For example, today I'm manufacturing a 150cc engine vehicle or a 16-seater aircraft. or a special purpose machine. It could be anything, like it may be taking care of some tonnage, or I may be working on some motors. I may be doing some 1 megawatt or 2 megawatt or half HP motor, whatever it is. There is a new requirement. How fast I can adopt all my dimensions, all my calculations, everything to the new product. So it's like ease of whatever that I get it, and how best I can utilize it, my dimensions. So as you can see, it's very clear. I can use the engine for any variant of the car, or use use the body of the heavy equipment machineries to fit to my requirement, or my customer requirement, or my client requirement, or my end user requirement. So that comes to our mind is how fast we get solutions for the new requirement or variants. That is very important for us. So whether my tool is capable of, or whether my system is capable of, whether our solutions are capable of, or is any market in the market we have such kind of solutions which will help us in quick adoption. Like we can say variant management. Variant management, when it comes in the broader level of product lifecycle management, when it comes to a designer level or engineering department or a design department or a R&D department, how I can play around with my dimensions, how is the information is sent to manufacturer through the design team. So these are the questions comes to our mind always when we see. Just we have we I just wanted to quick go to the evolution of the design process. There was a time in 1970s why the dimensions and drawings came into existence. We call it as engineering drawing or a machine drawing, like, and all the concepts was put into 2D design. Okay, so this 2D design would they started, probably they would have started from using drafting tables of what drafters and all this stuff. Then the evolution of few new softwares or 2D softwares, and finally that 2D software was capable of doing few iterations of whatever the changes we wanted. Instead of making 100 manpower, it was reduced to 10 to 20 manpower of doing manually to using the software. Now the 2D design, the 2D drawing was converted into 3D in 1990s. The Boeing 797, and I can say even the Toyota, and as well as the entire DMU. The DMU of aircraft was converted into 2D to 3D, and the DMU, the workflow, and as well as there is any clashes. It's like I'm walking inside an aircraft and seeing what is the issues and other things. The complete Boeing taken some of the solutions which I am going to talk in the later part. And then come in the today where we have our design or manufacturing need, or our sales people quick adoption, and we wanted to also assess our dimensions to manufacturing, and also the production, and also the quality checks and other things. That's the main reason that we wanted to bring the 3D design or the 3D master into existence. So this will become very easy for my communication. Okay. Now, so what if that I use this 2D drawing or a 2D design? What would be the problems that arises in the business impacts? Or you, as a company, whole company, or as a process or individual, you would have seen few challenges. So with respect to what is happening and how it is and other things. So just a minute. Okay. I think now it is resolved. Sorry, there was another colleague. Okay, now so when we see that there are a few things that comes into our mind, uh, that what is that happening in the by using this 2D design or 2D drafting. So predominantly there might be missing time to market on increased cost of operations. So this we call it. So what is the broader spectrum and what management is looking to reduce the few points with respect to this. This could be one of the reasons. Like if you're not connected, if my design team in the 3D level, if I'm not connected to the my people or my manufacturing or a production guy or my quality or assembly unit or whatever it is, are different units. So it becomes always difficult for the big pain, pain point for management. And also, so when it comes to engineering, you have to keep talking to other stakeholders. So you can say you have to talk to supply chain management people, or you have to talk to non CAD users or non engineers who they're into a different altogether, and you have to keep telling the information, feeding the information, explaining again and again what is that, what is to be done, and what is without any proper which only having a 2D, because they may not be having a such kind of understanding and mindset. So and the manufacturing, the difficulty understanding the complex assembly instructions. So you give it in a sheet, so or in a printed format and other things in a 2D drawing. So again, if it is something that is proven and it is used day on day on day on, and it's like proven product out. If you're doing for new NPD, again people come back and ask you, the manufacturing he may ask you. It is not that once like these are all the difficulties as a 2D communication which is happening in the usual or in the generic way. High costs of error from inadequate training and execution. So that could be another reason. And rely on engineering to provide no detailed product views. Time wasted reworking outdated technical instructions. So I can say the standard documentation, standard validations, and other things, and delays in bringing product to market, increase support costs. So when we say when we are in line to sales and marketing, that's how the company runs, and that's how the business, and that's how the new you get a thinking for the new product development or anything like that. And but so it becomes a delay. Like for example, like I'm working on even my competitor was also working on. My competitor is much equipped like 3D master and other thing, and he is producing the similar product what I'm producing 1 month before, or 1 month no, if I am delayed by 1 month or whatever it is. And again, of course, the training again. So every organization have their own training division, and they wanted to educate fresh engineers, or they wanted to start or there is a design a new product development, you get it, and we wanted to have a standard documentation and other thing. So that is possible. Okay, so these are few things that uh, as like we have observed in the market and taken some points. And when we see that, like how 2D drawing, my process level, if I see, like I'm not talking about the broader sense, like as a whole company. Now I'm going to the process level, like design, manufacturing, and as such. Too much time to find the right information, delays in programs. So you have to say, suppose there might be a chance in the 2D that you have referred to a revision. You are supposed to refer to the revision 10, and you have referred to revision 8, or on top of it you have a minor changes or major changes and all those stuff. So that searching and getting the information is again a very bad experience, and you're half the way to the production or whatever it is, and you realize this is the things, and you see a major impacts on the process level. Cost change process. So it's very much when you are a service oriented and you give a lot of to many other OEMs or many other it's like consumer oriented industries, there you frequently change your product. Like for example, the facelifts of automotives or whatever it is, you see that a lot of changes. So this will So this will impact my my production, and it delays and my orders and my business and my understanding, and I cannot go to the new product development and as such. So continued usage of non-correct unsynchronized 2D documents is what I was talking about. Like whether it is correct or incorrect, that I have to always keep in touch with my design team and get the information and all those. The product quality issues and customer dissatisfaction, and the too much time taken for quality understanding. Like so that is again, for example, like it is human. We may have some human errors also, and so when you go for specifically you know, the drawing, the 2D drawing impacts on design, manufacturing, and quality as such. As we already spoke, the multiple master formats complicate reuse. So it becomes very difficult, like which one to take it. So whether I'm in manufacturing, again I have to wait for the my CAD designer or a designer who has done this. No continuity among an increasing number of stakeholders. It's obvious that you are from the design as it goes to out of the design department. Engineering team comes into it. Supply chain management, procurement, or purchase department comes into it, and a manufacturing, a production, a quality inspection, many other. So now no continuity. What we say is when you are into 2D drawing, I just can put a remark in the drawing or in the soft copy, send it back. How it is impacted in the in the background, that I may not be knowing. Misinterpretation due to 2D drawings as a reference. It's a very big task. In we keep always talking to the purchase people in our day-to-day life. The designer goes and explain him, or to the manufacturing or a production. So what happens is here, if you see this, I've taken it from my 3D. If you see this image, it's all my in anyone's prospect. What it is exactly? It can be when I see this cross section and I can say it is rectangle, or I can say it's cylindrical. So it's all my misinterpretation, I can say, and it is not clear what is that I'm trying to say when it comes to 2D drawings. Cost of maintaining the integrity of 2D drawings during the change process. So what is the impact? Again, I should have a newer version of it. I have to copy that and create a new one, try to modify a few things. Again, I have to change my layout and other thing, and more time to get clarity in virtual assembly prototyping. So when you say 2D and you are working on a big assemblies, then you have to spend a lot of time to realize what is that is the drawing is going to is trying to communicate with me as a manufacturer or a production guy. And again, if it is taken to the after the production and manufacturing and quality or inspection or whatever, and the validation comes into it. So this virtual assembly prototyping takes a lot of time for my clarity. Instead of that, I can better utilize it. So it all depends on my understanding. So we need to spend a lot of time in 2D assembly drawings, I can say. And when it comes to tolerancing and GD&T, it's a non-semantic when you go for 2D, and I'm not sure from part to assembly level due to missing of 3D tolerances analysis, and generally which is based on best practices. So I'm not using any here 3D tolerances analysis here. I just give the dimensions and whatever it is I've done in the drawing, and I'm doing it. So whereas here, these are the few I can say business impacts which comes through 2D drawing. Okay, and when it comes to manufacturing business challenges, because they have their own challenges, managing the cost of the product complexity, evolving consumer expectations. So today, if you see, customers' expectations are highly demanding. So their expectations are we have to be very fast in the market, quick, reactive, and how fast I'm changing in my change action in my present design. And managing product complexity and diversity. So complexity because of the many new types of manufacturing. It could be Additive manufacturing is one of the example, like whichever I'm not able to the process which I'm not able to get it in the standard process, I can go for additive manufacture, quick reference or quick manufacturing or whatever it is, so that for the which gives me more durability and other things. So this is my one of the competition way, or complexity is going high. And established technology standardization and IP reuse. It's like I need one platform where I always talk about the design standardization, and which will also derive to my new product development and new technologies. So this will help me. So this should help me, or the manufacturers are facing a huge issues of standardization. So then the standardization comes from the 2D or like sorry, from the 3D level. We can see the major impacts on it, and managing complex changes across domains. So today we are like most of the manufacturers, they want to represent themselves in global level, or who are already there in the global level. So the change of the changes, what is happening across the domains, we have to address that. And innovation for a highly competitive market. This is again one of the pain points in manufacturer. They have to spend more time on it. How innovatively I can manufacture my product, how uniquely I can give it to the market. These are the points that manufacturing department keep always, they always keeping in their mind how best we can get it out and how best we can give the solutions. On top of it, we are in the 2D world. Again, we are going them and the daily process, whatever they're doing of they're taking reference of our 2D drawings and 2D detailed designs, and there are no clarity on it. And again, the impacts are going to delay with respect to delay, and again the business impacts will be there, and we may delay, or we may not be able to uh, answer to the new requirement, or answer to the new whatever that NPD we wanted to give it. And what is the 3D master concept? So now we are entering into the new technology which is called 3D master concept. So I can say few points of it, and then I'll go directly to the demo. So one is that one single reference in 3D. So I'm giving one single reference here. This reference will be, if I am a designer, I open this 3D master. All my instructions and other things are visible for me. The same I'll be giving him giving to the manufacturing or production or a purchase guy or even an engineering guy. So he can see the instructions. Even you can push it to the manufacturing also. If I'm using a NC manufacturing, I can see still that visible to my in the virtual validation, and you will be you will understand, or the designer will also understand, communicate, or he talks in language of manufacturing in the broader sense. 100% product information in 3D. So that's what we wanted, and accurate and annotate geometric definition, compliance with regulations and standards, manufacturing and work instructions. So these are the things that we can fast address. So if there is any issue, the person will come back and tagging a person who has particularly uh, designed this product, or given the detailed manufacturing drawing. So and other things. 2D is not that like we cannot say 2D is not required. It's like for our presentation we can put it, or for quick understanding that I want it in a paper. So I can give a still the option will be there. But I say that you'll not spend extra time for drafting. I can say here only that you will arrange the views. That is the only time, like 5% of whatever the drafting time, because you have already utilized maximum time in giving the 3D master in the 3D level. So reference in database for anyone, anytime, anywhere. So we have that system. We'll be announcing that in the last. So what is that system? We, so that every where I can justify my statement saying that reference in one database for anyone, anytime, anywhere. So and maximum data reuse. So whatever that we already have it in my present project completed or product completed, how best I can utilize that, and how best I can reuse it. So that is one. Direct feed for downstream applications. So like and also uh, the manufacturing, how easy we can get it from here, and if they want to put their point, that is also we can tag it back to the person who is in charge of that, or a design head or whomever it is. And 3D master end-to-end process coverage, the conceptual design, and that conceptual design, the detailed design, the design review, manufacturing design, and production and installation. So here we are not talking about anything with respect to 2D design or 2D drawing. You're all talking about the 3D master again with the 3D design. So it has some process. It starts with conceptual design, the detailed design, and the experience. If you have any changes that you wanted to make it, and the manufacturing and the production. So when it comes to the 3D master, enabling the digital community. So we generally come across a lot of exchanges with respect to from the conceptual to design to manufacturing and production. We are doing everything with the 3D, and also with our suppliers. We cannot leave our we have to grow ourselves with our suppliers by educating such technologies and making them also part of this transformation. And also when we say that, we can also show to your customers, authorities, like you are going for standardization or anything like that, and you have made some partners for technical partners or service partners or even educational partners or whomever it is. So you can have definitely share the details in all respect to 3D. So uh, so which will have better clarity, better understanding, fast understanding, and you can spend the time what you were spending in 2D, half, or even I can say it is reduced to 70%, or the remaining that ideal time what we are trying to give, or enhancing your time, so that can be taken for other activities. So I just a quick reminder saying that the 3D master does not mean no drawings. It will have a drawings. It's all left as a presentation. As I said, it means a 3D digital model as a single source of product information with the 2D extracted only for presentation. As I was stressing in my previous slide also. So this is only for the presentation layer. It's only a formality, I can say. If I want, I can just give a print. So I have to arrange the views and just take a print. The 3D master value proposal, that what we wanted to give it is the conceptual design, detailed design, experience, and manufacturing production, that we'll try to see one by one now. So I have a quick video for conceptual design, how conceptual design can help with the 2D layout in 3D design. So I'm just now opening. So now the designer creates is opening the 2D layout for 3D design. Now I'm arranging all my views here, and I'm taking my section and whatever that I wanted. So I just directly put my all my 3D data what I've done directly on this. Now you can see the window got split here, and all the sections whatever that I've done in my master design, the 3D master design, I'm just putting here. I'm not spending extra time here. I'm just sizing and allocating inside the layout. And what happens here is you can also see there are few changes that I'm doing here, and also I can impact the changes here also, and directly take the reference from my 3D, and it is highlighted in this 2D layout. You can see here. So this is what we call it as 2D layout for 3D design. So the impacts are happening in both the screens. You can see here. This is the understanding for what we get it from the tool from 3D master. So I'm bringing one more component here. So I'm pasting my component, and So this is my virtual validation that I'm doing at the assembly level. So parallelly, I'm working with 2D conceptual and as well as the 3D design. So I've opened this single part, and whatever that impacts I'm seeing directly, it is online. I need not to update any time here. So, and I've already done my drafting there. I've used my 3D master design for doing the drafting, because since drafting is another only a formality that I wanted to show. So as a so what is that we take from here is more flexibility. So as you saw, it is concept is one side and the drafting is one side. Then it becomes more flexibility and a simplification in early study. So and you can understand what is the manufacturing level of impacts which is happening at the early study only. That is one understanding that we get it from the conceptual study, and keeping everything in mind, single mod definition. So it's very much important for us. And when you go to the detail design, I'll start with the part level of detail design that we give it in the 3D master. So this in the 3D detail design, I've taken the same part here, extended that, and I'll show you how to make the 3D master dimensions. So it's like you are working on same, instead of only on the see here I'm creating the how you do it views in the part or assembly level, like in the drafting sheets. The same way you do it here. So but you have to tell, and it is more semantic. It will give me a semantic tool. Like if I select one of the heads, now you can see that it what the possibility it can have the GDNT, and I can make it as a reference, or flattening, straightness, or whatever it is, I can give it here. And the tolerances, if at all I don't want to give it as in GDNT level, I wanted to give my own tolerances. That is also possible here. You can see it in the radius level with the plus 0.2, say, and the other one. And I'm doing another sectional view here. One is that the front view I have completed. Now I'll take another scene, or I can take another section, and this is the section I wanted to showcase. Now in this way, I just communicate everyone with this, and I send this file in a neutral, in a readable format, in a lightweight, or it is only a viewing authorization if I give it to them, not a editing authorization. So it will be very easy for them to understand, and probably it once it becomes habituated in our system, then the communication becomes very fast, and we can also think about analyzing or think more time for the new product development. As you saw, I've selected this extended whole, and I've selected all my surfaces and what is the tolerances and other thing I wanted to give it. So we are going for the other section now. So what is that? It comes to my mind to give all those tolerances. What about the manufacturability? It is two ways. One is that the whatever manufacturability which is in-house, we have that capacity, or we have that provision. We can design in such a way, or it is left to manufacturing person. If he is able to achieve with traditional approach, he can do it, or he should go with like non-traditional, like new methods. He can do it. It all depends upon what are the limitations or tolerances he can achieve. So all these things I'm all the drafting views, I can say. I'm doing it in the, you can see in the view column, that is in the annotation set, captures and views. In that I'm capturing each and every view here, each and every sections here. So it will becomes very easy, and whatever that maximum material condition, other material conditions, whatever I wanted to specify, I can specify the leader text, the nodes, everything I can do it here. The surface treatment, they're specifying Ni 40B here. So all this, and I can have all the properties and other things I can do it. So this is how the detailed design is done on the part level of understanding. So once it is done, so I can give, I can filter whatever that I wanted on the view, and the same thing I can also hide here and hide here, or whatever it is, the views we have done. Now we can see it in the normal views of each specified section of views. Okay. Now in the assembly level, if we see how best we can utilize this tool. Now the part level, the understanding says is very clear and straightforward, saying that. So whatever the views it is there, that we can do it. So now we'll try to see what is that it is talking with respect to the same part level and also the assembly level with different parts. So in the assembly level, I'm specifying the same thing here, and with respect to the other part, and and I'm showing the now I'll also show the dimensions between one part to the other part, and I'm also doing the ballooning, and if I want to add some text and other things, that is also possible for me. So I'm just use that bracket for to do ballooning, and I'm using another another component. I give a different name or automatic ballooning, which we do it in the drafting regularly. And I'm taking another section here. So I'm going with a view. So, and so once I select that surface, it will tell me what is the best I can do it, or I wanted to give a dimension between two, uh, two surfaces. And whatever you can see what are the standards, the like H7 or whatever that hole or shaft standards that I wanted to specify. And I wanted to take some references, datum definition, and it has become very simplified. So I'm taking this axis system as my references, and what is if I want to give some for this particular role, if I want to give some position, that also possible to be given. And if there is a quick understanding, if there is any flaw or if there is any mistakes done in the concept, that you can directly double click on there and edit. That's what I'm trying to show there. Change the pocket, whatever the dimensions I wanted, and come back, and still I'm in the same assembly level. And see, I can collaborate. I'm using this Innovia lifecycle collaboration also. The best thing is, like, we have a lightweight, that is web browser. I'll try to show it in the web browser. So how can I open that dimensions and view? So it is not necessarily everyone should have the licenses. There are a few additional modules which will help me in viewing my different dimensions in 3D in the web interfaces. Okay, the key understanding, I can say, the quality improvement and error reductions, because in the part level, in the assembly, if there is any modifications you are finding, that we can directly answer to it. And in the concept level also, we have seen that how we can make use of 2D layout for 3D designs. The concept, that is also possible. Product definition accuracy improvement, so, and also the cost reduction, of course, that is a key thing that which adds a value with respect to when we adopt 3D master in different in our system, in simple way, directly reusable for any process. So you talk about the design process, manufacturing, engineering process, or quality checking process, or inspection process, or many other process. So even we can also involve sales, and they do tagging, or like as soon as they see this, show this to customer, and customer says that there's a changes, they just type it. That session comes to you, you can tag the people also. Productivity improved for parts family, so that is also very much important. Now we'll see the experience design. This one, so what we get it out of the box when we go with 3D master. So the real-time collaboration, so basically to there is a two engineers who wanted to work. See, I can say this Innova collaboration, and this is Katia assembly design. So one will work no, will be working on the conceptual stage, and the other one wanted to collaborate and help him out to do it. So so here you can see the two users are collaborated now, and they're trying to work on the same thing. And whatever the live update, I can say single source of truth, or single source of information, or more than that, more than that, I can say that, like, if the user is pointing out some changes here, saying that there are some flaws which we have observed during this 3D validation, I'm doing it. So in my lightweight format, I'm doing, and again he gives justification how what is to be need to be done for that to change the process. So now he is moving his harnessing to a different location to make sure that there is no clashes involved during our validation. So this kind of collaborative understanding which comes with 3D master when you are playing around. And again, when we have applied annotations, or when we have applied our 3D master system, so automatically you can see here that 3D master electrification automatically it changes in the background also. So I need not to spend extra time for me to even a small update with my drawing also, it is not required for me to do it. So the full level of experience collaboration that we can have it here. So that will help me in product definition available for anyone, anywhere, anytime. This we saw the example with collaboration experience, multidiscipline support. This is what we wanted on the any product development or existing products to get involved, like manufacturing techniques getting involved with new techniques where they introduced to design, and they improvise the process, they improvise the design level and other thing, real-time concurrent design and review. This is what we wanted. So the reviewer will review and tell that this is what, and the communication goes to him that fade outs the percentage by 80% or 90%. Again, the time repeats, the cycle repeats, and all those stuff. So you see that totally 20-30% of the time get wasted ideally like this. And discussion making with adaptive view representation. So whatever the discussions we make, that also can be captured here, and we can tag all the stakeholders on it. And then it comes to manufacturing, I'll show you another quick demo on the manufacturing. Here, if you see in the manufacturing, I'll also manufacture my part keeping all my dimensions open. This is missing in the 2D world, I can say, in the 2D drafting or 2D drawing. So you can see all my manufacturing. I kept my all FTA, my 3D annotations, 3D my symbols, GD&T, my tolerance, everything kept open during my manufacturing. That is, if you see here, Delmia Milton machining app I am using here. During my manufacturing, I have kept all my dimensions open. So this will be another added advantage. And if there is any problem, if he is facing, the manufacturer is facing, then he can directly see that and view that, and he can understand what is that he wanted to do. Now he's setting up all his properties to start the machining. So once the input is done, so he will start the machining. After the arrangements and stock and whatever the end product and other thing, whatever he wanted to give it, he'll specify that. So after he's specifying all the tool and other thing, now he goes and understand where I wanted to select. So now while selection, he'll also see what is the standard what designer is going to give, like diameter 10H7E, and what is the position tolerance, I can go for it. What is the reference for me? A and B is my datum reference. So this is what I can read during my manufacturing of it. So this is the part level of understanding. Even like assembly also you can get into it, like you can project big projectors, and all the design can be kept it in 3D and view it, or individually we can give them a display system where it can be a tab, or it can be a smartphone, or it can be some display system if we are introducing to our shop floors or assembly unit or production, or whoever we wanted to clearly easily communicate with each other. So this will become easier when we see annotations or going, and there will be option that we can definitely off that annotations if we don't want. So he continues with this spot drilling of whatever the process he wanted to do it. So with this, and he'll cross-check, verify, virtually validation becomes easier for me now. This is what I wanted to justify when I say virtual validation with prototyping, in assembly or part level understanding. So, and the machining process continues, and I can come back and validate whether all the dimensions are correct or not. And you can also set back to the designer also. And this is the machining process continues. Okay, and it comes the detailing. As I said, like it was 2D is only for presentation layer. So now what happens is in the presentation layer, I've completed my and I've created all my captured all my views and other thing. So I'll directly put it to my detail sheet. I select the sheet here, created instructions or whatever the template I wanted and whatever the color I wanted, I can represent here. So, and I just keeping my views here. I'm not spending extra time for it. So you can see already it is. So as I said, you will not spend extra time. Just give me a break. That's all. That is the thing you would do it. So probably 5-10 minutes for 5 minutes for arranging, and another couple of minutes for giving a print. Or if there is any validation, no, you wanted to verify it, you can take another 1 minute or 2 minutes extra. So this is what we wanted to do it. So this entire drafting, I wanted to achieve it by 3D master. So as we say, the 3D master value, what it gives us for a manufacturing unit is on-demand blueprint generation, which we saw, downstream application, direct integration, that for all manufacturing applications. Then it comes to production. The production, two things that we also see that. So one is that as I can show you this apps is a Innovia collaborative lifecycle app, and I'm opening this all my annotations with the 3D web app here. So this web app will allow me to show all the details at the production level, for inspection level, and for quality checking and other thing. And whatever it is, the changes and other thing that I wanted to specify, that is also possible for me to do it. I'm just selecting the capture and selecting the views here, whatever that I have done. And the best part is the inspection. Every manufacturing or a manufacturer will have his own inspection unit. That without that checks, it is not possible. So the other thing is like so people use 3D via Composer or CATIA Composer to do this. So we can, what is that it is delivering for inspection department, like this inspection table, all the thumbnails and other thing, you can directly load it, and whenever you are updating your part and this thing, it's directly linked to it. So I just create all my views. So whatever the views I want, just I'll create all the views here, which I have standardly prepared now. So if you are linking your 3D master along with CATIA Composer, it's possible. Other than that, we have an option of doing this capability within the 3D experience, 3D master. So where we can create all the inspection table and other things. So as a key takeaway, we can see that so the 3D leads to better understanding. Of course, that is what we wanted to specify, and IP protection for exchanges, and share the product definition to any production process. So the IP protection is very much important for, say, suppose I'm communicating back to my supplier or my client or my other out of my infrastructure, then what is that protection that I am keeping with my intellectual, that is also important for me. And we show you the two scenarios here. So the one scenario is for design department working with the 3D experience. So considering we have a migration path for 3D experience from category, whatever it is, or you already have a 3D experience. So designer works on CAD file and prepare MPD on the models, and he puts in it does in the 3D experience. All this you can open it in the lightweight mode. You can see it's the right part of the screen here. And production department uses the 3D viewer if they don't have synchronized, or they're not connected, they're disconnected at remote location, or your supplier are not into this 3D experience platform. We recommend on the first level that they also, you can also share them for a time or for one project or for one session or one scenario. you can share them, or you don't want to do it, we have a 3D XML. We have a 3D viewer app to view the data without any connection, like any WAN connection or LAN connection or whatever. We have it, and we have a lightweight format of all the 3D master you have done, that you can open that and view it. Okay, and so, and the other scenario is like the design department working with CATIA v5. You may be working with any of the CATIA file. So that CATIA file can be anything here. So in this format, any release, I can say any release can get into 3D experience, and you can work on MBD if you don't have a that is model based definition. If you don't have FTA license here, in the 3D master will help you creating all the annotations and all the scenes and all the sections and other thing. And the production department uses the same lightweight format of viewing the data, or from there directly you can take the print, or and the other one is you can have you can have you can have view it in the 3D viewer. So that is also possible to do it. So I have a small video which I've created for this on the tool. So I'll show you. So this is a typical 3D experience page looks like, and I'm just searching the part which I'm doing. So if you see all the web-based application I'll try to use, this is a widget that I'll use, that is a 3D annotation inside. So I'll just search from my search tag my whatever the part I wanted to view it. So I'll just search as a roller bearing here. So you can view, I get all the variants which I'm right now looking for, even a document. Yes, you can open that and show it. The inspection table which I'm talking about, you can open the Excel sheets also here. And if I click on the 3D annotation, so all the, just click on that particular part or product or whatever it is, I get all the data like this. So whatever the scenes I've done. So if you see, this is a lightweight format. I'm using the web browser to do it. I'm not using any heavy application like CATIA or native application of CATIA here. I'm just using the web interface here to do this. And now this becomes easy for me. In this way I'm justifying many of the which I've told in the PPT. That is IP I protecting your IP. This is what you can, which I'm specifying. I can give only the restriction access for my supplier, or just share the link to him. If he has a good internet, he can access to it. Or if he doesn't have good internet access, we have one more option to do it. Or your remote shop location or whatever it is. Yeah, I can view my datum, size, position, whatever it is possible for me to do it. I can change my background. I can even point out what are the changes that are manufacturing difficulties you are trying to you are facing it. So and we have another app which talks about, which is called 3D Play. It can 3D Play is something that we can know another app which can help me in viewing all the things here, like 3D annotation inside. That is that requires additional licenses, but all the platform license, whatever you buy it comes with a 3D Play app here. So I'm just, it's the same way, I'm just searching my data here, and I've got that, I've searched the data, and I'm just do a drag and drop, that is sufficient. Or just click on it, or you just contextual menu, you can click and say what is that I wanted to view it, whether in the authoring mode, or whether in the reviewing mode, or whether in the editing mode, or design mode, visual mode, anything that we can do it here. So in this again, I'm just it looks like very, and here I'm just doing the tolerances. So what is the possibility? Just click on that, which part I wanted to show the tolerances here. So this is all visible now again. So see here, I'm just using the 3D Play. I'm not going to the 3D annotation or whatever it is. I'm just showing it in the 3D Play app here. So this is the easy way of understanding, and you can see the, I'm connected to my cloud, and I'm just rotating here and everything. So I'm purposefully showing my cloud access, which given by Deso for the demo purpose. And I have from the native apps also. So in my native app, how best also I can do it. So this is the CATIA that I wanted. I say suppose this is the 3D file which is taken from the CATIA V file, and I'm just loading that and giving all my instructions, and I'm also opening that in the assembly evaluation, that is tell me assembly evaluation also. I wanted to show during my manufacturing process before I set up a machine, to the tool and assembly setup. So each department will have their own apps that we can see that, and this is how the interface looks like for CATIA part design or 3D master or whatever it is. So you can take all the sections, just click on particular section, and it will be visible for you. So that's how. Okay, sorry for that. And so now we can also have one more 3D viewer. So you can write to us. We will help you in resolving, or like if you have such kind of scenarios, we can work on newer scenario and tell how CATIA or 3D experience 3D master can help me in doing it. So we have already seen this scenario, and this is the scenario which I wanted to explain. This is the 3D XML viewer, 3D XML player. So you can see all the annotations or the datum references, the views and other thing which I have done in the 3D experience 3D master, or the freeware or the player which we give it to the manufacturing unit. They can view it on different views. As soon as I click on the front view, it will automatically be normal to my viewing angle. Goodrich Aerospace, so they have gone with the MBD approach, staying competitive and supplier involvement, culture change and training. They're used for many purpose, I can say. So benefits: elimination of redundant data and efforts, single source of data minimizes error, reduce the rate cost from 20 to 30%. And SAAB Aerospace, supplying Boeing 787 doors. They, as I said, the Boeing driving the SAAB Aerospace, saying that like you have to come with this 3D master. Under 3D master, what are the, so they say key achievements: cost of making changes to production process reduced to 90%, 3D work instructions on the shop floor, drawing time divided by 3. So this is what they're done. And the Ford, if you see, Ford recommends to use 3D master to its 500 plus suppliers. So in different processes like powertrain, chassis, mechanical engineering, configuration, body, NC machining, document automation tools, 3D functional tools and annotations, and many other things. And as a global references, if you see, many are there. So few we have only identified and we have specified in our presentation, and we have specific case studies. If anyone wanted how they are utilizing, please contact us. We can share that, and if you have any similar cases that we can do it or work with you by ready-made available case studies or ready-made footprints in across the globe, which Deso also can help us in the background. And today we just wanted to bring that whatever the opportunity, how getting to 3D master in an easy way. And so 3D master, how we can help you, what is the best solution, what is the best offer. I think my colleague friend Mr. Bharat will talk about it in my presentation. So one is that 3D experience. In today's situation, we say that like a business continuity should be there. Like we say that a business should always move, or we should say that whoever working in their perspective, or whoever working in their intellectual, so they should continue based on the outside world, what is happening, the pandemic situation or whatever it is. So we leverage this 3D experience platform on cloud, all the data on cloud, licenses on cloud, and many other things. Today, probably in another 2-3 years, we are already part of the cloud, but when it comes to mechanical application, Deso is the only platform which will help us in talking CATIA on the cloud and other things, and how it will be secured. The point comes, it is, we say the golden standards in terms of IT security, and it is so secured you can have a single sign-on, two-factor authentication, SAML-based integration, specific to asset, specific to the user. A login, OTP can be, such kind of facilities can be given to the local admin or user or IT or one of the project as an admin. So if any user is logging into the second machine, it will ask me, authentication will go to that particular admin head saying that he's trying to access to the other machine. So that such kind of facilities can be given. And this will be the typical page looks like when we go for 3D experience. This is the web page. I can say this web page has all the data, my roles, whatever that I'm accessing, the 3D search, 3D play, quick understanding, my own project level folders that I can create, and whatever the drive, how you have a Google Drive, Dropbox, or whatever it is, you will have your own drive. You can also have secure the files, the downloading data or uploading data, that however you're giving the FTP authentication, that is also possible to do it. And under this, so under this offer, we have we have all the brands. We have all the brands where we can do it. So these are all the no, the quick reference for the license no, under the brand that we wanted to give. So we are concentrating more on this CATIA brand. So in this CATIA, if you see that we have no 3D master designer and mechanism simulation designer, functional driven generative designer. I think it's Bharat, over to you.
Dassault Systems has come out a very good one-time special offer, which is valid. First point, it's an offer which is valid till 27 June 2020. And what this offer is, you can choose any one of the roles. In the previous slide, whatever Kiran has showed, you can choose any one of the slide on CATIA, as well as there are some simulation roles, as well as you have some manufacturing roles, a few manufacturing roles, which can be bundled, I mean, and provided you as a offer for just 30,000 for 3 months. It's a one-time particular 30,000, and that 30,000 is also a processing fee which is charged for cloud access. And if you look at the total ownership, or the ownership of the product, is hardly 10K per month per user. So we request you to look into this thing and to avail this special offer, which is valid till 27 2020, which is just not only useful, but it is you can also learn so many things on so many new. You can explore the new technology on this model-based definition point of view, and we request you to look into this offer. And you can reach out to us at any given point of time from the contacts whatever we have, or you can write to us at info@edstechnologies.com. Thank you.